How's the conference so far, people? Yeah, you can't wait for it to end, right? So it's the after party, right? And it's me being the only thing between you and the beers, right? So let's get it started. I get it. Welcome to the talk ESQL for the win. I'm Piotr Przybyl. I came here from Poland. I've spent a few wonderful days here in the Netherlands. These are my social whereabouts if you need to find me. I work as Senior Developer Advocate for Elastic. And today we assembled together to talk about this new language called ESQL. So hence, I mean, the slide, because I wanted to describe you the name. It's not eSQL or SQL, right? It has some like structured query language whereabouts or traces in it, right? But the proper way to read it is ESQL. And then because it's piped language, the pipe even made it to the very name. So it's ES pipe, QL, right? But the pipe is mute, okay? Okay, so who has ever been working with anything Elasticsearch? Okay, almost everyone in the room. Very nice. So for those who didn't, or maybe there are some people watching us on YouTube or whatever that will be uploaded, Elasticsearch, and this is my private definition, okay? It's not formal by any means. In my opinion, once you fit it with data, like from your, I don't know, database, from your files, from whatever, once you fit it with data, it becomes your own engine for search, for analytics, and also AI support, right? As Bala was kind to show in the previous version, previous slot, it can also work, I mean, Elasticsearch is a vector database, right? So it can be also used for all these vector operations, right? The question is to you, dear friends, how many languages can be used to hit the underscore search endpoint? We got 5. We got 4. 3. Okay, you said 3. Okay. Can I get any more? Can I get less? Okay. 2. Okay, yeah. 2 are frequent, right? There's query DSL and there's Kibana query language. The answer is many, right? And I think there's 8. So yeah, there's query DSL, there's Kibana query language. If you really want to go native, you go Lucene, and there are more languages, right, that were developed and used over time, over years, for like specific applications. Who knows this? Okay, sorry, that causes a question to be asked. How many Java developers do we have in the room? How many JavaScript developers do we have in the room? Some people are like, I'm not sure I want to admit. Okay, cool. You're very proud of this, sir. I'm proud you're proud. Okay, very nice. I don't know if you know, in JSON, JS actually stands for JavaScript. Okay, so this is like this little dissonance, like for Java people, because it's like the version without script. And anyway, this is the query DSL, right? And then when you go for these aggregations, of course, you can get more and more. This is how it gets, right? And me being like hardcore backend developer, let's say I have mixed emotions using JSON as a language, right? Not that it's not functional or something. It's just sometimes it feels like too much front-end, let me put it this way. So that's why I love this new hero, right, that can come or take like 3 shapes or 3 use cases. So it's this new language called ESQL. You use it basically by sending a post request to underscore query endpoint. So if you can just make HTTP requests from your language, you can, or even using C or whatever, you can use it, right? There's no JSON here. This guy is not Jason Statham, right? It's just AI generated. I had to get my $20 back. And it's there since version 8.14, right? So, of course, every new version adds more features, right? There are more functions and so on. So this is like, but the minimum GA is 8.14. And why 3 characters? Because this language helps us, or I will just go today through the language, like the language like as a syntax or the options itself, the engine that's underneath, and visualizations, because this language can be also used for visualizations if you're like more into Kibana world, right? So first, the language. The features, it's piped query language, handling structured and unstructured data, supporting SQL-like filtering and data manipulation, and lookups as well. So, who has experience with SQL? Okay, so almost everyone, I would say. Very nice. And of course, it's not the first piped query language in the world. There are other languages doing a similar thing. Perhaps you have seen this thing in your life, right? The backend heroes, right? Trying to get through the logs and everything because you don't have proper observability set up, right? So you have to do it like a savage. Okay, what does this do? Nobody knows. Yes, exactly. That's a very good answer, right? I have taken this picture and I couldn't resist the urge of putting it into a slide deck. So this happened in this very beautiful Utrecht of yours. 2 days ago, there was Utrecht Jack meetup, right? And Victor Gamov, who can't join this session because he's running his own at this very moment as we speak, was talking about like using SQL to monitor or extract state from Kafka, from streams, and so on. Let me try to zoom in. And he started by saying that actually when you read, sorry, I didn't capture properly the image. When you start analyzing a SQL query, you shouldn't start from select from. Okay, so from is the source, so then you first go to from, then you roll back to select, and then it's like, you know the story, right? So, very nice. I think Victor might like this new language called ESQL because it starts from index. This is literally how you start it, right? In Java streams, you usually have collections. Sometimes you might have split iterator or whatever, and this is how your stream starts, right? From something. And so it's the first clause in ESQL. You say, from index or indices or whatever. And then you pipe as many operations as you need, hence the piped query language. So for example, you can say that a field needs to satisfy something, right? So you can toss predicates. You can sort the documents, or we can see them now more SQL-ish way as rows, for example. You can say, I'm interested only in like first given number, right? Just like streams in Java, for example, we have a limit operation. Then in the SQL, we have select this and this and that, right? In what we can do in ESQL, we can say keep. So keep the fields. And we're saying this field, that field, another field. And mind you, because maybe you haven't noticed, this is a comment, right? So this is very useful because in this language, unlike some JSON applications, you can also have comments. Or you might decide to go the opposite way. So let's say you want everything, right, except these 2 fields, X and Y. So then you can go the opposite way, right? That's why you have figured by now, for example, that this is totally made-up query, right? It's syntactically more or less correct, but it doesn't make sense in practical application. But I have like working examples. And you can have this like multi-line comments. And now, I love questioning the audience, right? So let me go for, I brought you stickers in return, right? So after the session, please don't forget to come for stickers, grab as many as you want. So my question is this. Who has this file somewhere in your documents folder on your desktop that's called, for example, shame.txt, and you keep all these little pieces, of bash scripts or SQL queries that you use to investigate what's going on with the system? I see people like, yeah, you're too afraid to raise a hand. But we've all built there, right? We've all built there. We all have this file somewhere, right? And we, just like you have this jar with all the old screws and nails, right? We pass it to our children, right? This very file. So the idea behind this is this. This can be used, like for example, also to investigate like open telemetry and stuff, right? So you take these and you can just like shuffle them, compose them. You have these snippets. You might want to add, comments next to this snippet so you know what this snippet is actually doing, right? So then it's easier for you to manually go through this shame.txt or like, let's say, drive memory txt file. Okay. We can then process unstructured data, right? If it has more or less a format, you can just dissect this, right? This field as and get date, message, and IP address. We can calculate new stuff, so we can evaluate, for example, this thing. And from date field, we can like convert it to another type, right? Which means this is also typed language, right? It has types. We can then call this function extract year, and then we have just like we can override the date field. So as you can see, we can override. Calculate, override, and so on. We can have statistics, right? We can have, here, as you can see, we can have aliases. We can have more statistics on top of statistics, right? All expressed in this nice piped SQL-ish way, I would say. We then can call enrichment policy. This is, for example, if you have, Elasticsearch, as the name implies, for search, right? So usually you keep data flat, denormalized, right? But sometimes there's just one query you run once a month, that's like financial report, and it doesn't make sense to like denormalize this. So what you can do, you can have, for example, some data in some other indices. You can build enrichment policy on top of this. This will create for you this enrichment aliases, and basically you can sort of like join. Right, this would really like look more or less like left join from SQL world, or this is like one of the latest additions. You can just skip this enrichment policy, and if you're happy with the limitations, you can just go for a lookup join, and that's it, right? So you have lookup index, and you look up data and enrich the stuff you have in your index or indices you're looking from. Then again, you can search for some other data, perhaps in a different index, like order, using different fields. And as you can see, it's not like SQL when you have just one order by query. Like clause, right? You can have many. Then we can go again for limit, for a different limit, because we've done with our statistics, and so on and so on. So as you can see, this looks also sort of like stream in Java, right? So you can have as many intermediate operations, like you're not limited to calling like filter or map just once. You can call them as many times as you want, right? And so is this here, right? Okay, how to do that in Java? First of all, add dependency, and I really suggest going for the latest version, which is 9.0, also because this client has like a very nice way of constructing it, right? Instead of like doing it like using, I don't know, 10, 15 lines, you can do just 2 or 3, just toss your URL and API key. Then this is how you call ESQL, right? So you go ESClient.ESQL.query, and then you need to select the ESQL adapter. There goes the actual query, and you can toss any additional parameters, should you have them, right? And then there is the result. And we can have two kinds of adapters, basically. So first is this result set ESQL adapter. Who's been using JDBC in Java code? Yeah, many people. It's in Java since 1.2 or something, if I'm not mistaken, right? So basically, this will allow you, if you select this result set ESQL adapter, that the result will be of type result set. So any functionality that you already have that's calling, relational database now can be substituted with this, right? It will retrofit your current, machinery. And the other thing is that we can use is objects ESQL adapter, which basically will give us iterable of the objects of the class that we specified, right? And it looks like this. Actually, I should have a code in IntelliJ. So yeah. This is the code. See, so I have this client, ESQL query. I say result set adapter, which means that this is result set. Try with resources, very nice. It will like get auto-close and everything. This is the actual query, right? And then because I have used this syntax, I can also get the fields like this, like major and minor. In this very example, I check if my service is, for example, able to talk using the version 9.0. right? So this is how you can do that, and it's just results set next. I mean, it's idiomatic JDBC code in this regard. Or the other option is this. So we can have this. Where is it? Where is it? Where are you? Most published. Yes. So I just want to toss two parameters, minimum year and maximum year, to express the range, right? And I check an invariant, so I don't like flip them, for example. And then this is my query. As you can see, it can accept parameters. I can run some statistics. I can evaluate some fields, just sort using this newly calculated field. Then I can drop it because I don't need it anymore. I just needed it for sorting, for example, right? So it's not cluttering my wire or something. I just don't see it. But the interesting thing is this. See, now I'm using objects ESQL adapter, which if I toss the class here, will actually give me the results like using this very class. It's iterable of this class, okay? And what is this class? It's a record, right? So if you're going Java 17 or Java 16 and above, this is like what you perhaps should be doing. So if you just want, if you don't care, you know, about like this score and stuff like this, just give me, you know, this very few match documents. This is what you can do, right? Just you will get iterable. You can for each it. You can wrap it into a list or whatever. Just whatever works for you. Right, and I'm sorry if I sound overly excited about this, because as a backend guy, I finally enjoy a language that is sort of, you know, I've spent, shall I say, hours or days or weeks, or was it maybe months, you know, debugging systems like in production and stuff using Bash and SQL, right? There was no JSON involved. So in my understanding, now when I finally have a language, oops, sorry, later perhaps, right? Not now. That would be too much for demo goats. Now it's okay. I guess like the guys like from the US now are like suggesting me I should like update stuff. Anyway, what I like about this stuff, you see, I have taken this very query and I put it in Kibana, right, which is the browser very rich client, roughly speaking, or for Elasticsearch. And this is the beauty of it. I don't have to translate it to another language. I can just use it, and then I get results like this. And turns out the speaker was somewhat lying because the answer came back in, you recognize the format? Yeah, it's JSON, right? It's stuff JSON, not Statham. Yes, but it's okay. It's 200 okay. So let me go actually like roll back a little bit and go into these formats, right? So by default, the format is JSON, right? So you can specify the format being text. So it will give you this ASCII art table, like, you know, this underscore cat endpoints, for example. You can go for CSV. If you work for bank, right, people will love it because they can import it in Excel, right? If you're very hardcore, right, you can go for YAML format, right? And that would give you the YAML, right? If you fancy, like, if you spend more time in banking than with Kubernetes, for example, right? This is the format you may like. So as you can see, this is the same data, right, in 4 formats already, and the descriptive ones also have metadata, right, like JSON or YAML. So this is it. This is the list of formats. It's flickering. Is it me? Okay. Shall I switch? Okay, let me try to switch. Maybe it's me. Oh gosh. It's not flickering? Cool. Good. Another issue solved. See, I'm solving things as they appear, right? Very good, nice production. Anyway, this is the list of formats, right, available. And I was told that, for example, our data science friends love this last one, which is arrow format, right? There's a format very much popular in this, you know, data scientists for Python, so we can get data in this format as well, right? So there are binary, human readable formats, and so on. You just specify them using format parameter. And you can play with this as well. I mean, even if you just want to get like your hands dirty with the language, how it works and so on, what you can do, for example, is go to this ESQL demo Elasticsearch page, right? And then you can play. So see, I copied the same exactly the same query again and run it there. So it's nice because it works for backend, frontend, Kibana, what have you, right? And if you go for somewhat more sophisticated query, as you can see what it does, because previously there was just one document, right? What you see is doing is already like giving us visualization, like chart for it, right? And the list of matching documents as they appear. So you update the query and the results are like sort of like already updated below, right? If you don't like this stuff, you can of course go for a different format. And now this enrichment policy, as I told you, so this is like what you can do if you have some extra source fields, source indices. You can create this enrichment policy that will give you the enrich index, and sort of you can use it for this joining, right? So to get this not to flatten or like enhance every document you have here with these fields coming from these indices. But I told you this language was started in what, 8.14, right? And there are new, like with every new release of Elasticsearch and Kibana, there are also like new additions there. So for example, there's repeat. Now we can have filters per aggregation stats. So as you can see where status is like at least 500. And it's divided by service. We now have also like full text search or query strings. We now have the score if you need scoring. We can have KQL if you have, you know, nice crafted KQL query. Now you can embed it there, sort of decorate it, for example, to ease your migration, so you don't have to translate everything from Kibana query language into ESQL in one shot. And there is this nice command lookup join, which I mentioned, right? And this does the following. So this might be actually easier if you like query things less frequently, for example, and you're happy with using this so-called lookup index as depicted here. Maybe this is okay, and you need just less ceremony to get your data properly than with this, you know, enrichment policy and stuff. This quickly shows what you can do. There are like some limitations. For example, it works only with lookup indices, and the lookup index is a special new type of index, and the biggest limitation or a property of it is that it can exist only in one shard, right? Because if we were like then, you know, first collecting the documents, then calling again all the nodes and so on, that would take too long, so I guess. So that's why it's only one shard, but it gives you this nice SQL-like behavior. Right, to get your data enriched with this lookup join command, which is similar to enrich, but not exactly the same. Let me jump into the engine, right? So there is this wall of text, and I don't want you to read it. That's why I kept only, I think, the important parts, right? So the engine is basically a separate component. It's when you send a request to _query, it is handled by somewhat simplified, but it's handled by the same, by a new engine, right? Written from scratch, and it has different performance characteristics. It's not exactly the same. I would say in many cases it's faster, but sometimes it might not be faster, hence different, right? And how does it work, or what is it using? I'm using here, maybe I will show that in the examples, but I'm using here, you know, start local. So, come on. Why does it want to get smaller now? I messed up something with the screen. Let me see. Or with the window, sorry, with the window, I guess, yeah. So I'm using it from localhost, right? It's running in my local Docker, and when I run it, then in my Docker, this command, right? So inside this container, I want to see what are the processes, right? So you can see this is the process for Elasticsearch, right? And how does it work is this. It adds this module, which is 10th incubator, right, for Java 25, and for 24 it's 9th, called vector, right? And this, as you can see, also means that this whole Elasticsearch inside this inside version 9.0 is running using Java 24. Okay, but this is not magic. This is like solid piece of engineering. So in Java, there is this concept of incubator modules, and you can cherry pick them, right? And this one coming from Project Panama enables Java to operate using these SIMD instructions, which stands for single instruction, multiple data. And let me maybe illustrate it with this. It's not AI generated, right? No graphic designers were harmed during the process of creation of this because, as you can see, I created it myself and I'm a backend developer, right? So I'm sorry for the poor drawing, but please stay with me when I explain what it does. Let's say I'm recruiting you, okay? This is one array and this is another array. And the challenge is following. You take first element from here and first element from this array. You have to sum them, like add them together and put in this array. How will you do that? It's not a tricky question, trust me. How will you do that, honestly? What's the first solution coming to your mind? Yeah, exactly. Like run a for loop, yeah? Write it in a for loop, yeah. So with a for loop, we end up with something like this. We take first from here, we add them together and store here. And we take second, repeat, and so on. And so the story goes for all the elements, right? And now the thing is the following. Let's say these are integers, okay? What is the size of integer in Java? 4 bytes. Yeah, 4 bytes, 32 bits. Now, your CPU, let's assume, I don't know what CPU you're running, said it's also different for your like Linux machine or Mac machine or like cloud environment and so on. Let's say it has registers, your CPU has registers which are 128 bytes big, okay? Which means if we do this sophisticated mathematics, that you can squeeze in 4 integers actually in this register, right? And this is the whole magic, right? Instead of doing this one by one, what we do is this. We take first 4 integers, we put it into one register. We take 4 integers from another array, put it into another register, and we run single instruction, like add these integers I have loaded into my registers. So in one CPU cycle, all right, one CPU instruction, I have result for just 4 elements in the result array, right? And it's not just for addition, it's for like other stuff you do with numbers. And as we know, right, in computer science, many things could be expressed just by numbers, right? So this whole vector API from Java is using this. So it detects what CPU it's running, right? And if you write, instead of like for loop, express this using this new Panama API, then it will detect it and use us or squeeze as much data as it can for single instructions. So that's the whole mystery behind this, right? It's actual proper science in engineering, okay? And this is a benchmark taken in November 2023. So shortly before I started working for Elastic, it shows this thing that, as you can see, this is the search framework, like let me call it the classic way, right? And it got this massive drop here, more or less when there was work on this ESQL engine. And this massive drop, it means that 2 things. First, that when you have shard partitioning, ESQL is somewhat slightly slower, right? But this classic one had like a massive drop. But if you go, for example, segment partitioning and stuff, the ESQL is faster. So as you can see, for some things, it's better to still use query DSL. For many, it's better to go for ESQL. But why the drop? How many times have you implemented a system? Sometimes we do the rewrite, right? Or sometimes you write like solve similar problem. And this is, I was told, what happened. So when creating this new ESQL, component, developers understood that some things could be backported to the old one to also get performance improvements. So this tells you two things. Sometimes it's nice to have like a fresh look at stuff you're developing. Second, it really makes sense to keep your Elasticsearch up to date, right? Because even if you stick to this query DSL, you might get better results because of, like, I don't know, new field types, better like modern Java with better garbage collectors, and also because things get, you know, improved when it also goes to performance. Let me go for the last step, which is visualization. And did I tell you already I'm not a front-end guy? I might have. Yes, I might have, I guess. Anyway, that's why I have these images prepared. I'm perfectly honest, I've taken this screenshot myself, like 2 days ago, I think, or, yeah, sorry, no, June 2nd. So, sorry, I was cheating, not 2 days. 3 days. Anyway, do you recognize the view, Kibana? Yeah. So how to like start playing with ESQL? It's quite simple. There is this button here, try ESQL. You press it, and it will switch into this ESQL mode. Let me try if I can see this. See, it's this. Switch to classic. Okay, discard. And see, I'm clicking try ESQL, and it will give me this results, right? I can then click this ESQL help, and this will give us, for example, recommended queries. So let me go, for example, with, I don't know, create a date histogram. Bah. So when you see it in one of the next slides, I'm actually not that smart, right? I just use this functionality, okay? But what you can also do here is this nice thing. You go quick reference, and now you can go and start, for example, you don't even have to have two monitors or open two tabs and switch between them, okay? You just have the documentation of the quick reference right in front of your eyes. So if you're interested about this lookup join, you click it here, and it tells you everything what you need to know, or at least start working with it, right? Right in this window. So this is how this visualization is working, right? So we did this, yeah, the help, and yeah. See, this is the query from a demo, ESQL demo Elastic, right? And this is this more sophisticated, you know, time histogram. But maybe we will need something stupid, so not to have it as a, you know, bar chart, but let's have a pie chart. Right, it's doable. So you can change the visualization, you can save it as lens and so on, and that's probably explained better in this short video. So as you can see, there's like a completion, right? It knows the fields you have in the indices. When you do stuff, and then when it makes like a sense, then it should update you know, the list of documents and the charts and so on. Yes, as you can see, we can sort, and that gives us nice visualization. We can now save this as a lens, just like with the query DSL. We can tune it because, yeah, perhaps there were too many. Yeah, 12's okay, yeah. Cool, and now we can do, of course, the regular stuff. So we can clone the lens. We can now change the way things are found, right? So instead of going for countries, we can go for regions, and yeah, copy paste. I love this part. Yeah, just copy and paste. Yeah, who would type it again? And then we can change it to be like the cloud tag. Sorry, tag cloud. Yeah, so you see this. It can work like this. So it's, and this is the, like, the way I love this. Maybe I've mentioned that as well, is because for me, for backend guy, this finally means, sorry, this slide, as you can see, I'm not good with front ends. Like when I have issues, right, trying to understand what this query is doing, what I can do these days is the following. I can switch to Kibana, I can craft the query, understand what it works like visually, and then I can go back, right, to my Java code and copy it back and stuff like this. This language is being worked on. So it's not like It has many, many features, but it also has a decent, like a feature requests list. So add this, support this, and everything. And the philosophy was the following. Instead of waiting probably endlessly until everything is implemented, right? Let's do the following. Let's release a language with sophisticated set of commands and so on. And then we will add them along the way, right? So every new version has like more statements, more functions, it has performance improvements and so on. And there are like limitations also regarding to fields. For example, which saddens my little backend heart, is, for example, still dense vectors are not supported or nested fields are still not supported. But the list gets shorter and shorter with every release. For example, half a year ago, full text search wasn't working. And now these days it's working with match function, right? And so on. If you need our help with this, like you tried this reference, you tried your AI agent and it's hopeless because it's like a new thing, so it wasn't trained on this. What you can do is the following. You can go to our free, let me say free open source forum, which is Discuss Elasticsearch, right? You can tag me or my colleagues. And the nice thing about this, and also the Slack, if you're more of a Slacky person, is that the people who actually work on this can answer your questions, right? So you either go this or that way. You can also attend our meetups. So the closest one, I believe, is in Amsterdam. So we had a meetup yesterday, right? And this is the link. So if you need to go for this Discuss or Slack or want to attend our meetups, you can just scan this or go to elastic.co community, right? It's the single place for you to start as a community member. This slide is because sometimes you can't make it to a meetup, right? So what I do is, and I can do it on site or I can do it like virtual or hybrid, it's called brown bag lunch. So basically, during the lunch break, instead of going somewhere else, you just we meet in your company's premises, right? You bring your brown bag with your lunch, right? And in the meantime, we'll be talking something Elastic related. That's like no NDA, no fees, but also no consultancy. And that would leave us with few minutes to actually run some demos, right? So let me just change quickly because we'll be experimenting, right? So I love this. Like a crazy scientist version of mine, lab code reminds us that this actually, things might explode and go wrong, right? Because I'm just a human being. And yeah, so I have what you see here is a gist that's available for you online, okay? It's available for you online. And if you want to start, Elasticsearch and Kibana locally on your machine, you just need Docker, right? Something that will understand Docker Compose. And then you go here for GitHub Elastic Start Local, and that's it, okay? And you run a simple script like this, and it will start like a trial, all versions for a month or something. Yes, and you end up with this local host, or as the German friends say, local Horst. Yes. Anyway, what I have here is this. Right? We have sample data, so I have client IP of type IP, I have message of type keyword, I added some data, and then we have client IPs like this, right? Or, because I want to show you not this enrichment policy by this lookup, see, this is it. This client IPs as lookup, right? So this has this index in mode lookup, right? And the mappings are still the same. And I added the same stuff. So if I now go somewhere down here, which should be, where are you? Let me go and actually find it. And that be not this one, not you. Yeah. So what do we have in this index? See, oopsies. Unknown client IPs. Sorry, typo on my end. Yes. So we have these, and I even imported it twice. See, I was so eager. And now this is it, right? So I have my sample data. I hope it won't explode because of these duplicates. Let's see if it explodes. Yes. No, because it's typo again. Sorry. See, typing is not my best. Anyway, see, this is what you can do. The original data just has the IPs, right? It doesn't know the environment. This environment is coming only from this lookup index. So I'm now able to, on flight, right, during runtime or this query, find this out. So that's one of the nice features, right? There's more. One thing I would suggest for this file, this precious TXT file we keep on our desktops, is the following. And of course, you can run them, as I said, using like Seer or whatever. What I would suggest is, or maybe you can tell me, where is it? Where is it? Where is it? I'm just trying hard time. Yeah. See, we can have multi-line comments, right, or single-line comments like this, but you can do it like this, you can do it like this, and you can do it like this, and all three give us exactly the same result. So what is the difference between them? The position of the pipe, right? So I would say this is the absolute madness, and you can do it like this if you hate humankind and your future self. I mean, some people like it, I was told, so feel free. You can add it here at the end, but I would say the preferred way, or the way I use myself, is put it like in front, because then you can like easily shuffle the the order of this, right? And there's of course limit. So if we don't run it with limit, see, let me try something like no, not this thing. Sorry, this thing. If we try with it with limit, I get like 5 results only, right, as you can see. And then if I try it without limit, it yells at me that it added the default limit of 1,000, right? So this comes from the, like it's an environmental variable. You can tune it, right? Because else it would like need to pump everything. So that's why we usually, or I suggest just to add this limit. And there is this difference you see between these queries. This one is post and this one is get. What would you get with the get request? An error. And this is intentional, right? So despite this is query language, it supports only post requests. Why? Because some routers or firewalls are very strict and they say get requests cannot have any body or payload, right? So just to avoid this confusion, can it be post, can it be get? It's only always post, right? You can't get working, okay? So that's the thing. Yes, we can toss and have these, metadata fields. So if you need to know which index it comes from, what's the version, what's the score, what's the ID, you can add them here with this metadata. You can filter, right, or you can't if you just use single equals, right? So we need to have 2 equals. It's not SQL, okay? You need to go like more like in Java, like which is equals. It has the concept of types, right? So as you can see, for this one, it got dynamically converted into IP type, whereas here we did it explicitly. Okay, we can select if something is null or not null, right? We can filter, for example, using this event duration or whatnot. We can go for like or regular expression, like if you go into regular expressions, which means a question has to be asked. Probably the last one today. Do you know what's the plural of regex? Regex, you know what word regex, right? It's a singular, right? We have 1 regex. How do you call 2 of these? Regrets. Regrets, very nice. Regrets, yes. That's why maybe like is better, I don't know. And now we can also go, as I told you, full text or like text matching, right? So I can let me see if I imported this. Yeah, I did. See, so this is like is Windows or Linux, right? And then it goes, it knows that these are stop words in English, right? You know, just regular Elasticsearch, business, BM25, and so on. Your experienced people, they have explain this, and it just leaves us with Windows or Linux. Hence, we have. These from the logs, right? We can go for query string if you fancy query string, or by default it goes. I don't remember what it goes, but yeah, we can say just keep URL, for example. Here, that's the difference. So I only know the URL. So as you can see, we can play with this. There's Kibana query language if you fancy something like this. We can go with the statistics, and there's more in this gist I prepared for you. So don't hesitate, just grab it and run it and so on, because we're running out of time, or I'm running out of time. Yes, now it's time. I'd like you to feedback, right? To tell me and the organizers what was okay, what wasn't okay, apart from putting it as a last, slot, so everyone is tired and just dreaming, like, give me beer, give me beer. Okay, maybe not. If you're watching this on YouTube, right, I would like to ask you to do two things. First, fill this little survey. I mean, if you're in this room, you can also fill this survey. This is anonymous Google form, right? I don't know who you are unless you introduce yourselves. And if you watch this on YouTube, please hit the subscribe button, right? Maybe the bell as well for the great organizers of JSpring. And these are the links for today for you. So this is the ESQL demo. The next one is how to start ESQL in Kibana locally. If you prefer to go for a free trial for, I don't know, like 2 weeks or something, you can go Cloud Elastic.co. Right. If you need the documentation, it's here waiting for you. The gist with these commands is there as well, so you can play it. And if you fancy the Java code, it's the last link. Right, if you want to experiment with Java code. And with that, bedankt. Have a great evening.